Now on to our next inequality. Again, our first step is to find the domain restrictions. We're going to set both of these expressions, which are under a radical, to be greater or equal to 0. Simplifying, we get x must be greater or equal to 5, 4 on top, and x must be greater or equal to negative 1/3. When we take the intersection of these two restrictions, we see that x must be greater or equal to 4/5. Now we're going to square both sides of the inequality. 5x minus 4 plus 2 times the square root of 5x minus 4 times 3x plus 1 plus 3x plus 1 must be less than 9. 8x minus 3 plus 2 times the square root of 5x minus 4 times 3x plus 1 is less than 9. Now we have to isolate the radical term. We can add 3 and subtract negative 8x on both sides. Then we can divide both sides by 2. Finally, we have to establish some new constraints. We know that the output of a square root must be positive or 0. And because 6 minus 4x is greater than this value, 6 minus 4x itself must be positive. So our new constraint is that 6 minus 4x is greater than 0. 6 is greater than 4x, and x is less than 3 over 2. Now, since we got our new restriction down, we can go ahead and square both sides. And let's expand the left side. We get 15x squared minus 12x plus 5x minus 4 is less than, the right side becomes 36 minus 48x plus 16x squared. And let's move all the terms to the right side of the inequality. X squared, we're going to plus 7x on both sides, so we get negative 41x. And then we add 4 on both sides to get plus 40. All this is greater than 0. We can factor, so we have x minus 1 times x minus 40. All this is greater than 0. When we look at this, we can tell it's an upward opening parabola because its leading coefficient, 1, is positive. So if we want this parabola to have a positive value, it must be when x is beyond its 2 roots. So its 2 roots are 1 and positive 40. So x is less than 1 or x is greater than 40. Now let's intersect all of our conditions. We have our domain here. We have our sign constraint that we developed later on. And then we have our algebraic solution. The first two, if we combine it, gives us the restriction that x must be between 4/5 and 3/2. And when we intersect this with our third algebraic solution, the upper bound becomes 1. So this is our answer.